Next up, we have a session on misinformation, and you can have conferences on misinformation. Not seemingly sponsored by Facebook, but there you go. So the sort of theme I dreamt up when I was working with the committee to put this together was sort of a whole question of how we look at misinformation from sort of a retrieval perspective. And we got two complementary experts today. Again, one from business, or strictly speaking, David, a charity, and Andy from a university perspective. So it's going to be very interesting to see, again, two different perspectives on this theme of managing misinformation. So Andy, I think you are up first. So if we can get you hosted, and there we go.
Okay.
Over to you. I can indeed. Yeah, brilliant. Thank you very much.
Okay. Well, welcome everybody. So what I'm going to talk to you today about is a Google DNI funded project called DMINR. And it's very much what I'm trying to do is I'm going to try and give you an overall broad view of how of journalist information behavior, essentially, and how both exploring information and verifying sort of go hand in hand, as we found. So before I start, I'd like to acknowledge all the people who worked on the project. So Colin, Glenda, Stefan, Maricela, and Saunders, plus some other people who did some technical work. All of these played a very, very essential, essential role in this project, and it's a product of all our work. Okay, so I just wanted to make, I'm basically presenting on behalf of all of these people today. So what I'm going to do, my agenda really is, firstly, is to just give you just a bit of background to DMINR, some rationale for it, why even consider this, and then sort of dig down into the sort of journalistic context for DMINR. Specifically, what the sorts of things that when we were looking at doing this, or building this tool, that we needed to consider. I'm then going to briefly talk about a newsroom investigation that we did. We actually managed to get into the BBC and the Times, which is very, very difficult, and that in the context of the journalistic context that we had, and just tell you about some of the things that we found, not all of it, just some of it, and then talk about the DMINR design and implementation, and then I'm going to risk a demo. Okay, so we've got a minimal viable product. There's a lot of work to do, but the demo does give you some of this, give an idea of some of the things that we're trying to deal with, and some of the problems that we're trying to solve, and then at the end just give you some conclusions and way forward, and then I'll supply these references at the end with some of our key publications so far. Okay, so really the background to this is journalists, essentially they're very, very, they're typical information workers. They use information all the time, and they indulge in quite sophisticated information behaviors to generate stories, particularly obviously to find information in order to generate these stories, but also to manipulate it as well. And including those in those information behaviors, they have a number of critical working practices, including obviously exploring a variety of information spaces. So, going to a magazine, or going to television, or going to Google, and bringing all this information into their stories, and they'll what they will do simultaneously is we found that they verify them. They're not separated. They'll look for information. They'll be constantly verifying and trying to make sure, is that true? Where do I check it? Do I cross-check it? How do I do that, etc., etc. Now, a lot of this, up until fairly recently, a lot of these practices took place an accident would happen and a journalist would turn up and they'd sort of interview people and they'd cross-reference and they'd do their information behavior would be actually in person, speaking to people, verifying them. He said this, does it match? Can I find a third person which I can verify what they say, for various reasons. So there's a big challenge here in terms of certainly the digital space. So it's all moved to the digital space, the variety of information available in the variety of different sources, the massive information, and also the accuracy of source. You go to Wikipedia thinking, I've really got to check this. So there's a real interest here now in building tools to support the automation of information behavior in the workflow. Okay, so automating the workflow to support information behavior is something that's of a great deal of interest. And what we're trying to do with DMINR really is to help that. Essentially is to look at things that journalists are interested in, people, places, organizations, find them, extract them in terms of entities, and build links between them so that we can try and build in verification schemes. And you'll see how we try to do that later. So the journalistic context, this is something that we had to consider here. So there's a lot of interest in AIs to support journalist workflow, and it is increasing. There's a chap at LSE by the name of Charlie Beckett who's done some very, very interesting investigations in AI and journalism. Is well worth looking at. Now, the thing is, journalists do see the benefit. So removal of menial tasks, having to go through several different sources from here, and here, and bring everything together is a bit onerous. So removal of those menial tasks is important. And also things, as we found, serendipitous discovery, being able to support that kind of activity is also very, very useful. But there's cultural, a lot of cultural resistance here, like fear for jobs. Is AI automatons going to take over, and are they going to do the writing for us? And there are other things to do with AI and ethics that are very prominent in the space now, that everybody, particularly to do with GPT-3. So there's a lot of issue here that we need to deal with. Now, the way round this, we think, is to build in journalistic values. And there are many of them, but things like transparency, for example, where did you get the information from? Accountability, who's responsible for this? Well, and responsibility. So those are the key things, really. And if you can do this, and I have to say, it's not hard, it's not easy to do this. These are very, very abstract, very, very abstract terms, but considering them, we can think about how we can engender trust. And that's really what we're trying to do. And eventually I'll get onto this idea of explainability. So we took out this journalistic context as a basis for a work, and we actually got into newsrooms, into the BBC and into the Times. We were very, very lucky doing this. It's not easy getting into newsrooms. They are very busy places. They don't like to be interrupted. They can be very secretive. They're very, very busy, and they don't like being interrupted. Sorry, I just repeated myself, but I'm just emphasizing the point. So we got 14 journalists, 9 male, 5 female, not an ideal balance. We prefer more females, but sometimes that's the way it works out. So what we did, we examined the information behaviour of these journalists with observations and interviews, and we took typical information science, largely drawn from prior work in journalism, in terms of finding what journalists doing, finding, validating, interpreting and using. I'm not going to. We've got a journal article which is in preparation at the moment, and there's a lot to say. But there's one particular recommendation that that proved to be key for us, was providing background information, and this gave us an idea really around sort of extracting the key facts from data and multiple sources. And this really inspired our approach of thinking about, okay, journalists are interested specifically in people, in organisation, in events, and how can we extract these and create the links between them. So this really inspired our approach. So what we did was we had a number of co-design workshops. Obviously, because we had journalists in there, the journalistic values that we could consider to be important took centre stage in those design workshops. We had a multidisciplinary team. We had working journalists. My colleague Glenda Cooper, she works in the journalism school at City, actually still is a working journalist and teaches journalists how to do journalism. Colin's very much, now he's now in Switzerland, he's very much on that. We also had HCI people. We had Stephen Macri, who's an information scientist, and computer scientists like me and Saunders. And what we did was we generated wireframes iteratively. We came up with some ideas. We had Stuart Scott, who's the head of our interaction lab, who manages our interaction lab, come up with some designs, and we iterated through those with the team. And we came up with this sort of search functional visualization for the data. So you'd have a search, which I'm going to try shortly. Hopefully it's still working. It hasn't crashed. And try and build up connections between them so that users could investigate them, those entities and different types of entities. So initially we thought of actually building our own machine learning scheme to do this, but ultimately BERT came along, and basically it's so easy to take BERT, plug it in, generate the entities and the relationships between them, and essentially that's what we did. Although we did use BM25 actually to rank the most popular relationships. So this is what DMINR looks like in practice, and this is what I'm going to demonstrate now. Okay, so hopefully you can see. Can everybody see my the DMINR system? Is that Martin?
Yes.
Yeah. Great, thank you. Right, great. Okay, so what I'm going to do is I'm going to do a search. I'm going to try and demonstrate this, and I'm just making sure that the service is running, because sometimes it crashes. It's yeah, it's still running. Brilliant. So I'm going to look for. So consider a scenario. I started off. I'm quite interested in Philip Green, so I'm looking to develop a story, perhaps around Philip Green or something related to that. Okay, so simple search, traditional search, and I've got a number of tabs here which I'll go through. So you'll notice who is Philip Green, and I've got some tags. Actually, that's not from our tags, that's actually from something called Inject. So but we can replace those with ours if we so wish. So at the moment I've only got one source. And I can, this is a bit of a placeholder, I can change the date eventually. So that's a traditional type of search from one source. But not only am I searching one source, I'm also searching some, essentially in this case, it's Companies House. We did have a link to Open Corporates, but that appears to be broken at the moment. So I can look at Companies House, either companies or officers. So, you know, that's one thing I can sort of verify. And that's another source that I can look at in order to bring in to verify my information. And I can also go to Google as well. Okay. But the key thing here is the Explore Connections tab. Okay. And eventually it will come back. And this will show me Philip Green with a number of different entities, different types of entities. So I've got some people here, Robert James Crosby, some organisations, so the Work and Pensions thing. There's also some Jeremy Meeks. There's a bit of an error here. The Xiaodong, which I'm going to have a look at, is actually an organisation. So we have got a bit of work to do with that. So we've got some ways to sort of navigate. The visualization at the moment is very, very simple. I can zoom in or zoom out, and this is really eventually where we can build up quite complex visualizations, and journalists can gradually build up quite a complex information space. As you see, you'll be able to navigate through the information space and build up a view of what they've looked at and sort of connections that they're interested in. But that's really a placeholder at the moment. So, you know, I can have a look at any of these. I mean, looking at Robert, I know Robert Drain Crosby, I had a look at that, and that's merely because this particular chap who was in charge of HBO was actually stripped of his knighthood along with Philip Green because of some of the dodgy things that he was getting up to. But what I'm going to do is I'm going to have a look at this Xiaodong Roy, that's how you pronounce it. So what I can do, okay, so I'm a journalist, I've not heard of this before. So what's the connection here? So either I can just have a look at that and just browse through, see what they're, that in this case it's actually an organization, not a person. Or I can browse articles linking Philip Green and Xiaodong Rui. Okay. Hang on a minute. So that's interesting. So this is a Chinese giant, Xiaodong Rui, trying to take over Topshop, which is actually owned by Arcadia, which is essentially Philip Green's company. Okay, so I'd quite like to explore the connections here of this particular. So remember, I've got a definite connection between. I've got in the independent. I've got a clear evidence between Philip Green and this company. Okay, it's been reported in the media, so I'm on solid ground here if I'm generating my story. So going back to explore connections. So W.L. Ross, that's interesting. So I've got lots of, they're actually in other places as well, something that unfortunately we're going to have to resolve in terms of disambiguation. Still got a bit of work to do there. So we click on that and let's just maybe sort of browse articles. Okay, so they're in talks with another, with Xiaodong Rui, the company that was interested in Arcadia to build another stake. Okay, I'm a journalist now. I've got a story. I've got a deadline of 3 o'clock tonight. I've got something interesting here to say about this company, Xiaodong Rui. Not only are they interested in Philip Green, but they're also interested in Arcadia. They're also interested in OCM. So then I've got a lead now, and I've got some evidence now that I can verify my stories. So you can see what I'm doing is I'm simultaneously exploring the information space, but also what I'm trying to do, whilst I'm doing that, I'm trying to verify it. And I can do that because I've got the sources to do that. So I now just go back to my slides, and I shall just finish off. So that really was the demo. As you can see, it's just the broad view. We've got a lot to do with regard to I'm going to say that anyway. So just to conclude, journalists require support to explore and verify information for their stories. And this is what the DMINR, as I've tried to demonstrate, is trying to do. Our report research provides some ideas how this can be done, but keeping the key journalist value in mind. So this idea of transparencies, and this we did a usability test with BBC and Times journalists. Transparency came up, and explainability came up. So what we're trying to do now with this system is trying to provide a much more sophisticated visualization that provides a lot more transparency, where we can click on the link and see what the type of link is. We haven't implemented, we just didn't have time to implement all of our design. It's, it looks very simple, but actually there's a lot of work that's gone into this. And what we're trying to do is to provide some sort of, we're looking into explainability in order to support this transparency, and in order to support the key journalistic values that we need to address. We're trying to provide a lot more of explainability in system. Now, I know with AI and NLP, that's a big issue, and we're not going to solve all of that. But what we can do, with our interactive visualizations, we can provide support for making sure that the sources are clear, that the links between sources are clear, and give the journalist the control over the information, so that removing this fear about AI taking over their job, and treating them as Peter Ingleson's, the most important, most intelligence system in any intelligence system or intelligent information retrieval system is the user. So giving them control and giving them information, all the intelligence is used to bring back the information, but the journalist makes the decision. In order to do that, we need to build explainable systems, and that's what we're trying to do. So that's really all I've got to say. So hopefully I've got a few questions to answer. And so over to you, questions.
Well, we take the questions at the end, Andy, so that we can.
Okay, fine.
We can synthesize what David's going to say, because he's coming at it from a different perspective, but we may come up with some themes. So, David, can I switch to you?
Yes, please.
David works at Full Fact, and if you don't follow Full Fact on Twitter or Facebook, your life is much less informed than it should be. Currently, Full Fact, I think, has what, 220,000 followers. Anyhow, we're following you today, David. So if you can do, you might want to do a little bit about Full Fact.
Will do, yes. Before
you inspire us with the work you're doing for them.
Thank you very much. It's good to be here. But it's good to be back here. I think I last spoke at Search Solutions about 5 or 6 years ago now, when I worked at Signal Media, so Signal AI. And before that, I was working with Andy MacFarlane at City University. So it's nice to be amongst friends. So yes, I'm going to talk today about claim matching, basically deciding whether 2 sentences mean essentially the same thing. But yes, by way of introduction, really, I want to talk, first of all, a bit about Full Fact and what we do, why we do it, and what kind of technology we're developing. So full fact is really motivated by this notion that bad information ruins lives. I think we're all very familiar with the phrases around fake news and disinformation and so on, but it's easy to forget the people who actually are affected by it. Yes, it can ruin their lives. Over the last couple of years, of course, we've all become very expert in coronavirus, but the misinformation around how it's spread, more recently about how vaccines work and whether they work, whether they're dangerous, can lead people to make very bad choices about their own lives, on those lives of people around them. And other areas, there's problems with sort of democratic credibility. If there's bad information going around who is eligible to vote, or what policies different parties are representing, this can undermine democracy itself, which should be of concern to everyone. So around 10 years ago now, Full Fact was set up, and it's now the UK's leading independent fact-checking charity. And we ask people to correct the record when they get things wrong. We campaign for better information in public life. And to do this, we develop new technologies to counter misleading claims. While we are political, we do not take sides. If you look at our website, fullfact.org, you'll see that we're founded by a cross-party group, and our board of trustees is still very carefully designed to represent a wide range of political views and parties. And a key part of what we do, as well, along with campaigning, is to monitor the news primarily in the UK and keep track of things being claimed by journalists and by politicians and other thought leaders. And we therefore employ a group of journalists, about 9 or 10 journalists, who, as Andy was just saying, sort of constantly are seeking information and verifying that the whole time. And their job really is to, when they find information which is actually damaging, potentially harmful, misinformation, to then write a fact check, try and explain that information, provide all the context to our readers, who can then make their own mind up about what they choose to believe. So my role is, as a data scientist, is to try to develop technology to help out this process. And almost 3 years ago now, we're fortunate, along with fact checkers in Argentina and Southern Africa, we won a grant from Google.org, the non-profit bit of Alphabet. And this grant basically was to help us accelerate our AI development, to create new technologies and then get those used by fact checkers. And as part of this process, really, we did a survey of fact checking organizations in 20 different countries, and asked them basically how they thought technology could potentially help them do their work more effectively. And the answers basically came back under sort of 3 headings. One is, the first question fact checkers always say is, what's the most important thing to check today? So certainly at Full Fact, it takes often a day or even longer to check one fact for one person. So this is a very time-consuming process. It involves, identifying the claim to be checked and then saying who exactly made this claim, what exactly were they saying, what was the audience, what was the context in which they were expressing this. It may involve going back to looking at some original source document or database, if figures have been quoted from there. It may involve contacting experts and saying, can you give us some context? How should we interpret these claims? And then writing all that up in a very clear, objective, open way, in a transparent way, so that our readers, as I said, can then look at the website and read these articles and make their own mind up about what to believe. So speed is therefore very important. And the second thing that fact checkers ever ask for is how quickly can they check claims? Is there any technology which can speed up that claim checking process? Whether this is verification or finding evidence to support things or finding links between stories, as in the DMINR project. And the third thing they ask for help with is to discover when someone says something that they've already checked. So after a fact check has been published, after one of these articles has been published, other people may still come along and repeat the original misinformation. And when that happens, if we know about it, we can respond very quickly and say, point them to the existing article, say, hello, we already know this is misleading. Maybe consider publishing a correction or a retraction. So I'll quickly go through these 3 claims, the 3 requirements really as technologies we have developed and are still developing really at Full Fact. So the question around what we should check next. We basically have a tool which scrapes content from the UK digital news media, so basically, the main newspapers and some social media around sort of the political part of Facebook, basically. And we saw all this text in Elasticsearch, and then we index it using various technologies. And then let our fact checkers search over this to find stories that they think are worth digging into. So, for example, one thing we do is to use a quotation recognition system, which tries to figure out who said what. And then we link that the speaker through their wiki ID using name identity recognition. So that in this kind of context, if you search for the line at the top here, in this case, the user searching for anyone who's in the Conservative Party. So we have a list of known IDs or people who are in the Tory Party as Conservative spokespeople. In this case, he knows that Sajid Javid is the same as Mr. Javid, and potentially you can recognise just as he or as the Secretary of State for Health, all referring to the same entity. So it means that you can do a very similar search to get back a lot of relevant information. The question of how quickly we can check claims, we do have a very early stages of a prototype, which I won't be demonstrating today, on fully automated fact checking. That's the ultimate dream of AI in this kind of space. It's a very limited scope, but the idea is if there are sentences which contain a very specific claim around a particular number, where there is a trusted source of that number, such as things like measures of inflation or unemployment, we can tend to extract the information from the sentence around what number is being claimed, what's the trend being claimed, what's the date that this number is being claimed for, and then verify that against trusted sources. At the very least, this can pull back useful evidence to help fact checkers make their own mind up around whether this is worth digging into more. As I said, though, this is very early prototype, so I won't be spending too much time talking about that today. I said I really want to focus on this idea of claim matching, of deciding has someone repeated a claim that we've already checked. So when someone said something that we know is wrong, particularly if they're a journalist or a politician, we can ask them to correct their record, either by withdrawing an article or by issuing an addendum to it, because we need to know that they've said something wrong before we can ask them to do this. And also, once we have published an article, if the claim is repeated, we can get more value out of that article by reusing it, in effect, by just pointing people at the old article, even as the claim is repeated. So we need to decide basically whether two claims therefore are saying the same thing. Is a new claim saying the same thing as the claim we've previously checked? And one way of thinking about this is to decide whether two claims have the same truth conditions. In other words, are they talking about the same state of the world? Or put another way around, is there if you change the state of the world, does it make these two claims both true or both false? If so, then they probably are at the same underlying truth, which is equivalent to bidirectional textual entailment, if that's more familiar to some of the audience. But in layman's terms, it means, are these two claims saying the same thing? If you believe that one is true, doesn't necessarily lead you to believe that the other one is true as well, and vice versa. That's the problem we're trying to solve. I just want to go to one recent example of this. So this is a fact check article, or the header of it, that we published a few weeks ago now on the 9th of November. A classic kind of error this is actually the Daily Mail as it happens. So some scientists did a study which showed that there's a correlation between going to bed at a certain time, at a reasonable hour, and having a lower risk of heart disease. Because this gets reported as if you go to bed early, you won't get heart disease. It's reported as if there was a causal relationship, which is sadly not true. But after this fact check had been published, we then found this had been the same false claim had been repeated in different outlets, the Huffington Post, which again says that there's a causal relationship. You can reduce your chance of heart disease by going to bed at a certain time, which is again sadly not true. But we need to find this using the technology. Before I go on there, I'd like to say that if you look back at the original fact check, this is a new feature on our website. This pink box at the bottom shows that you can actually see the actions we've taken. So in this case, we contacted the Daily Mail and said, points out this was the study was about discovering correlation, not causation. And they did actually correct their headline and the first paragraph of the article to clarify this. And something we found over recent years is that newspapers are increasingly willing to to correct themselves if we point out politely they've got something wrong, as long as it isn't too partisan, which is encouraging. We've actually got correction now for most UK papers, even for places like Russia Today. And I think when he was Prime Minister, David Cameron did once in the House of Commons acknowledge he made a mistake and point out by full fact, corrected himself. So that's nice. We do actually have some impact. However, I would say that this task is a hard task for a number of reasons. One is just that language is ambiguous. Every word has multiple meanings, every phrase has multiple interpretations. And so finding an exact semantic match between two different sentences is almost impossible. So you have to stop things slightly and say, are these two very, very similar, even not quite identical? But always interpreting expressions of natural language is always a challenge for a computer to understand that, or to model it out and process those things. It requires so much real world knowledge to interpret what is being said. The context in which a claim is made is often also critical to understand the claim, but also often missing from the way the reporting is limited, or the way we scraped it, but you have a single sentence in isolation. It sometimes can be hard to decide whether two things mean the same thing if the context may be different. An extra challenge, of course, is that truth varies over time. If someone says inflation is 2%, they were right, some months and wrong other months, depending on what the current figures of inflation were. So working out whether two claims saying the same thing or not, you also have to consider, are they making the same claims about the same point in time? Otherwise, you get nowhere. Another main problem is one of scale. So at full fact, we collect every day something around 80 to 100,000 sentences every day from, like I said, UK newspapers, from Hansard, the parliamentary record, and some social media. And if you want to keep track of repeats of say the last 100 fact checks, which is about 6 or 8 weeks worth of fact checks, that gives us, basically multiplying those two together, we get to 10 million pairs of a sentence and a fact check that we may want to compare and say, are these actually saying the same thing? Well, actual matches are very rare. It's hard to know for sure because we don't know about the ones we don't find. But when we do find, we're expecting to find, at most 10, 15 matches per day. Therefore, of course, most sentences will never match any claim we make. Most people aren't talking about things we've already checked because people talk about a huge variety of things. And so the vast majority of pairs of a sentence and a fact check don't actually match each other. So we really are looking for a needle in a haystack. And this bias in the data set has it makes the problem hard, and it's driven a lot of our research and development into trying to get around this problem. So how do we do it? What technologies do we use? I've been working on this problem at full fact now for about 18 months or so, and it's been a challenge at times. So I want to take through not the whole process because we don't have 18 months spare. I want to take through some of the methods that we used. I started off, actually, before I joined the organisation, with simple sort of a keyword search, so that the people writing the fact check or other colleagues could specify a few keywords and a simple Boolean query to say, in the example I gave earlier of the sleep and heart disease relationship, you can imagine searching for heart disease and sleep, and maybe get some of the positive matches, but it's quite hard to define that kind of query on the fly. We basically found it worked well for some claims if there was a distinctive number or phrase associated with the claim. But often it's quite easy to search over our database and find lots of matches, lots of relevant matches. But if there was no particular distinctive phrase, if it was a claim about an individual with a lot of articles written about them, for example, then you get a lot of false positives. So this was kind of useful, but didn't really solve the problem. So more recently, we started looking at BERT because everyone looks at BERT these days, and in particular, we used sentence BERT, which basically is designed to measure semantic similarity between sentences. So it can, given a sentence, it basically returns a vector pointing to a point in some sort of semantic space, with the idea that if two sentences mean roughly the same thing, then the vectors should be very, very similar. And so we can use cosine similarity to say, are these two sentences semantically related? Which is a big step forward for us. But the problem there is that often different entities have very similar semantic profiles. So you think of a pair of sentences like Boris Johnson expressed concern about rising inflation and Emmanuel Macron expressed concern about rising inflation. Yes, semantically they're very, very similar. And a model like BERT would say, well, Johnson and Macron, they're both, leaders of Western democracies, both middle-aged men. They're semantically very, very similar. Because to a journalist or to a fact checker, they're different people, and therefore the inflation rates they're talking about are different inflation rates in different countries. So it's totally unrelated in that sense. But to a model like BERT, they would look very, very similar. We also had a problem during the early stages of the lockdowns, when lots of fact checks would be written about different cities. Is Peterborough in lockdown? Is Liverpool in lockdown? Of course, they're different places, and so have no particular relationship. But to BERT, they would just, oh yes, they're interchangeable. They occupy the same part in a sentence. So BERT got us a bit further, but didn't really solve the problem either by itself. So we looked at entity recognition, named entity recognition, and tried to say, well, if BERT gets confused by different entities looking similar, perhaps we need to count, are these actually the same entities? So we used Spacey just as an off-the-shelf solution to identify the entities, and that helps a bit because many claims don't have any named entities in them. So this wasn't enough by itself. And so finally, we had the sort of insights to put all these things together. And we started working what we call our meta classifier. So this is a single machine learning model. Actually, it's a multi-layer perceptron, but different models fit in quite easily. And we tried to combine all these different sort of inputs as features, or different features as inputs to this single machine learning model, which, I hope this makes sense. So the idea is we take a sentence from the media and a fact check, and then we put them through bin25 as a way of saying, which fact check would you retrieve given this sentence if you search over all the fact checks? And that gives us a score of a similarity, essentially based on word frequency and that kind of TF-IDF that we're all familiar with. We also put the same two sentences through the sentence BERT model and get the similarity scored there, and through the named entity recognition, account how many entities they have in common. Take all those features, put them into multi-layer perceptron, and that then produces as an output the probability that these two actually are a match. And this kind of framework gives us a lot of flexibility in that we can add new features in the middle quite easily. We can experiment in this part here with adding in USC and other vector models of semantic extractions, phrase embeddings, and so on. And it works better than any single solution by itself we've shown. Because now we're introducing machine learning, we need to therefore get some training data. So this is where there is one advantage of being a charity over an industry. We don't have much money, we don't have many resources in terms of the technology and staff, but we do have a lot of supporters very keen to help us. And some of these people had previously been in touch with us saying that they wanted to help us out but couldn't afford to. If you can afford to, please do go to the fullfact.org website and find the donate page and give us all your money. Thank you. I'm paid to say these things. But we also have people who say, well, we can't give you money, but we do have spare time. Is there any other way we can help you? So recently we set up a crowdsourcing page to let our supporters try and engage with us more effectively and actually help us create useful training data. And this is what we produced. And again, if you've got time after the conference, there's a URL at the bottom. You can go to the webpage and click on the Get Involved section, and you'll see a pair of claims like this, just doing two sentences. And the question is, do they mean the same thing? And you click yes or you click no. And that helps us, feeds into our model, and we can improve the quality of the model. And to me, a lot of these seem quite straightforward matches, or they're obviously not matches. However, when we look at the data from our followers, from our users on the website, there was quite a lot of discrepancy. So we end up collecting quite a large number of annotations for each pair of sentences in order to try to get a sort of agreement between them. We recently started using binomial theorem to try to work out how many annotations we need before we can decide whether there is actually a confident agreement between the users. So having over the last 2 or 3 months now collected quite a bit of data, managed to produce this graph, which thankfully does show that more data does help. So this is showing that on the x-axis, we have the amount of training data. As we get more annotations moving to the right, the P@10 score improves. So that's to say, for each claim we're looking at, this is in a small test set. For each claim we're analysing, the number of predicted matches in the top 10 predictions, which are correct, does rise over time. But if you're sharp-eyed, you'll see that the maximum we find is still quite low. This means basically, if we showed our users 10 predicted matches per claim, probably only one of those would be correct, which is not a fantastic score, but it's better than we had previously. And this is the actual tool we've now built. So this is available to our fact checkers to use basically every day. It gets rebuilt, and it shows in bold some of our more recent fact check articles, or the headlines, the claims that we investigated, basically. And under each one, it shows 2 or 3 snippets of text from newspapers, which appeared, according to the model, appeared to be repeating the claim itself. But some of this works very well. So over here, you can see the claim that we are short by 100,000 lorry drivers, and the sentence here from I think the Express. Again, it is an article making the same claim that we are short of 100,000 drivers. Notice though, it doesn't actually mention lorry drivers in the sentence here, just qualified drivers. Doesn't say whether they're taxi drivers or ambulance drivers or anything else. But from context, the model has decided, yes, these are the same, it's the same number. So yeah, it works well. I see that our users are giving this a nice tick, so that they found this is a match. Just go to a couple of other examples here. This is quite a fun example that this claim that this is a claim that's been argued back and forth for many, many years. The claim that Scotland subsidises England. This article actually says that there's a subsidy to Scotland from the rest of the UK. So saying the same claim but with a reverse stance, which is kind of interesting one to follow up perhaps. One other nice issue is that this Facebook post up here. So we have a claim here about the amount of food being subsidised to MPs. I think I'm saying that both these links take us to the Full Fact Facebook page. So actually we're finding our own claims that we've checked and published ourselves. So it's kind of circular, but it's reassuring that the system is working. So I showed you the graph earlier of the F1 or the P@10 score, the precision at 10. We had quite a lot of problems with actually evaluating the quality of the models, and it comes back down to this issue of the we're trying to match those rare events. But we have a test set which is 5 days of media, so I think more than 400,000 sentences, of which we found 100 or so which matched 100 positive cases with matched relevant recent fact checks. And we use this test set to basically evaluate models, so we can train up a whole series of models, estimate the accuracy, the F1, and so on. But then when we tried to deploy those models, we often found that a model which appeared to do very well on the test set, which didn't perform very well live. And I think the issue is that because there are so few positive examples, that it's basically a very noisy set of data. So that a model which makes almost the same, 2 models which make almost the same predictions with few differences between them, if one of them happens to miss out a known positive example, its precision score will go down massively, even if it's actually almost indistinguishable, and perhaps in some other ways better than the other model. So we switched over recently to be more sort of results focused, and now before we deploy a new model, we do a sort of as live comparison, so we can actually see how they behave on a real set of data in real time over a week or so. And basically we end up with a spreadsheet, and then we can do a visual comparison and say, is this actually better than the old model? Rather than worrying too much about an estimate of the F1 score, we actually see, does it actually do better in reality? If so, then we deploy it. So this is still very much a work in progress. Our plans for the kind of near future, one is obviously is to carry on collecting crowdsourced data, and hopefully that'll improve the model over time, fingers crossed. We've also been collaborating with Chequiado in Argentina over the last year or so on this, and they've helped us produce a Spanish language version of the same tool, which they are currently evaluating. And next couple of years, we're hoping to go seriously sort of multinational and make this tool available to people in other fact-checking organizations around the world, which does mean we have to move away from English. which is going to be a big challenge. In theory, it should be okay. You know, BERT and BIN25 are not sort of language specific, but this obviously will require quite a lot of work. And the other thing we're looking into is using WhatsApp. We do receive messages through WhatsApp. People are saying, I saw this thing in my family group, is it true? And the hope is that if we can verify, if we can match those against known fact checks, we can then automatically reply saying yes, and here's a URL pointing at our relevant fact check. So yeah, that's what I want to say. Normally at this stage I'll be saying, you know, I'll be at the back of the room having lunch, please come and join me. That'd be a bit weird, given that I'm at home now. But if you do want to get in touch, please do any suggestions, especially around multilingual NLP. I'd love to hear your thoughts. Otherwise I'm happy now to take questions from the floor. But back to Martin.
David, thank you so much. Fascinating. The technology that sits behind this has to be matched quite clearly by the skills of your team. You really are enabling the team rather than saying, here's some technology, it's going to take over from you. It's clear that you couldn't build this technology without the skills of the people that are around you.
Yes, absolutely. It's something that's been kind of quite eye-opening at times, is that we have to focus on what they actually need. So for example, on this claim matching problem, showing that screenshot, there's no point in showing the users thousands of potential matches. They're not going to read them. We need to show them about 50, it turns out. They can read that in 2 or 3 minutes and say, yep, that's worth following up, that one's not worth following up. And that's all we have. And so understanding the user's requirements helps us guide how we actually then develop the technology.
Tony Russell-Rose, you've got your hand raised, Tony.
Yes, thanks. Great talks from both. In fact, I got a question for both speakers, but maybe I'll just do David's first, seeing as that's the most topical one right now. What's your thoughts about? I thought it was really interesting how you've done the pipeline of the sort of classic methods and BERT and then the named entity recognition. What's your view on like linked open data and other sort of curated sources? Do they have a role to play in this? Because I know there's a ton of stuff out there with like DBpedia and the other one that I always forget that's built using Wikipedia, and you can do sort of Sparkle lookups on those. Do they play a part in this at all, or is it all using sort of distributional and the techniques that you talked about?
It's a good question. So for the quotation detection stuff, we do use the wiki ID of every named entity. So basically, we have a regular lookup against Wikipedia, I think using DBpedia to group together different synonyms of the same people primarily, but also organizations. So yeah, the short answer is yes, we do use some open source indexes like that. I don't think the only thing offhand here is the wiki ID for named entities.
Yeah. Okay, great, thank you.
Did you have a second question?
Well, my other question is for Andy. So
yeah.
I don't know if you want to do both at the same time.
Yeah. Well, you got the floor.
Yeah. All right. Thanks. So yeah, likewise, Andy. Really enjoyed your talk. It's just a simpler question. What's the current status of the tooling that you built, and is there a publicly available instance that we could all have a play with?
It's currently a minimal viable product, so it's not particularly stable. For example, the BERT module, which at the moment is sucking up 3.5 gigabytes of memory. So it's a minimal viable product, and it's a bit it's not publicly available yet. I mean, we're not really sure what we're going to do with it. I mean, there is some idea of maybe commercializing it, which is what the Google DNI fund want us to do eventually, or produce something where it's open source. So I think we still need to do a little bit more research. For example, we've got to build we've got to implement the wireframes more completely. As you can see, it's a bit sketchy at the moment, and we've only done a very usability evaluation, and we can't really do a full-scale evaluation until we've built it. But we need money, so we need to do more research. So just watch this space. I'm looking, just hunting around, trying to find money with my colleagues so we can take this further. I really don't want it to stop now. It'd be such a pity after all we've done.
Yeah.
And we've got some really good ideas, I think.
Yeah. Are the project partners currently using it though in their workflow?
No. It was just a city. It was just a city project. So Google DNI funding, normally you have different partners, but it was just us. So it's a collaboration between computer science department and the journalism department.
Okay, I get it. Great, thank you.
David, I've got a question on chat from Ingo from Holtz about what kind of external sources do you use? Academic, preprint repositories. Can you give us just a sense of where you look?
Yeah. So this is really good, kind of the skill of the journalists, the fact checkers themselves, who will know where to look. They would normally, I think, talk to an expert rather than try to interpret the literature directly themselves. It can be very technical. So, for example, if anything comes up around the climate, we tend to refer that over to different organisation, Climate Feedback, I think it's based in Paris, who are experts in that kind of response. So yes, I don't think we go this directly. We do use the Office of National Statistics, the ONS, who publish the official figures around inflation, unemployment, and so on. And we do use that database automatically through their API. But scientific stuff, we tend to go to, we'd rather phone up an expert, phone up a professor and say, is this claim true or false, rather than trying to understand the papers ourselves, more usually.
Because one of the problems you must run into, a lot of the science stuff is sitting behind the subscription paywall, so you can't get at it.
Yes. Yeah, and newspapers too, which is a shame.
Yeah. Any more questions coming in?
Yeah.
Udo.
Yeah.
Hello.
So, thanks a lot, both of you. The City University is quite overrepresented here today, but not anymore. You just mentioned, so David, you just mentioned Office of National Statistics, and I remember a talk a few years ago that either you get, probably not you, it was probably Will Moy, somebody from Full Fact, and I had the impression that initial claims were sort of largely matched against this sort of structured data. I imagine you're moving further and further away from it now, are you? So, I mean, what's the sort of fraction of claims that you could match by looking at ONS records versus things that come in and that people are interested in, which you cannot match like that?
Yeah, really, the ONS covers primarily macroeconomic data. So basically, when the budget is published every year, the next day, there's thousands of articles about what is the actual rate of inflation, what is the rate of unemployment, and then we guess potentially we can match a lot of those against the ONS data. The rest of the year, however, it's always much more widely spread. Obviously, a lot of debates around sort of, coronavirus and vaccine effectiveness and pickup rates and so on, which are available through other government dashboards. But primarily in those cases, we let that be handled directly by the fact checkers. They can go to those websites. They know where to look. They know what the latest figures are, and so we don't need technology to figure out what the claims are. The automated verification tool, the prototype I mentioned in passing. We're hoping to plug into that other data sources, including the government COVID dashboard. But I'd say most claims that are actually damaging and are contentious are usually some more complex claims around cause and effect, for example, which is harder to pull out of a database.
David, a thought from me, to what extent are you thinking about sentiment analysis on claims and the extent to which, the way that it's worded helps you interpret whether or not it's an accusation or whether it's a statement?
It's a good question. I think Phil Fact did publish a sort of a guide for social media users to try and spot fake news. One thing they said is that if you read something and it makes you feel very, very angry or very sad or very upset, pause, think about it. Why is it making me feel so upset? Why is it so emotive? And that's often an indication that it can be somebody trying to manipulate you into believing fake news, because it can be a genuine story which is genuinely moving. So we don't automatically estimate sentiment, because it's not very. It can be a useful guide, but it's not in itself a reliable indicator of truthfulness or not. A very flat headline can be with no sentiment can still be saying something quite devastatingly accurate or inaccurate and dangerous.
Okay. Well, David, both you and Andy, thank you very much indeed. A nice matching pair. It's you're approaching the same problem from slightly different directions and with slightly different objectives. But this is such an important topic that we as IR specialists should be thinking about and seeing how we can help both you and Andy, particularly if we have money to spare.
On your side, yes, thank you.